So, welcome to this course, Classical Electromagnetism Part 2. Part 1 was given at the same site bsc.hcverma.in, and that was Classical Electromagnetism. I had given about 2 years ago. That was basically on electrostatics, and electrostatics, you know, when the charges are at rest, essentially at rest, and they produce electric field. So, that production of electric field, its relation to the charges which are producing this field, then if the field is there and the charges are there, how they move, then interaction with materials, if we have materials, conducting materials, insulating materials, and then there is an electric field. So, how do they interact? Those things come under this electrostatics. So, this was electrostatics, and in continuation the next part we will be giving in this course, and this part 2, which is starting today, that will be on magnetostatics. So, you have electrostatics and you have magnetostatics. So, in electrostatics you have electric field produced by the static charges, and here you have magnetic field produced by the constant currents, okay, not changing with time. So, in electrostatics you have some Q1 placed here, some Q2 placed here, and so on, and then they produce some electric field. So, this is how the electrostatics is described, and these things should not change. There should not be any time dependence on the charge distribution in principle. That is the definition of electrostatics. Although if there are small velocities, it does not matter much, and we do apply the laws of electrostatics for slowly moving charges also, okay. But these charges should not change with time. So, if you talk in terms of the charge density, then this d rho dt, this should be 0 for electrostatics. Now, here in magnetostatics you have currents, I1, I2, you have different currents, and these currents produce magnetic field. So, this is E, and then these produce magnetic field, and if these currents are not changing with time, if the same wire or same material in which the current is going, the magnitude of the current, the direction of the current, they do not change with time, we call it steady current. So, if the magnetic field is produced by steady currents which is not changing with time, then this area is known as magnetostatics, okay. And so, we will be talking mostly about this magnetostatics in this course, depending on how the course goes and how it evolves. We can do some other things also, but basically it will be centered, focused on this magnetostatics. For those who have joined this site for the first time, let me tell something about the management of the course. Of course, if you are here, you have come through this only. So, this is a site created by IIT Kanpur, and the platform which is used in this is called CUET, and you have all registered on this. That is why you are here in this course, that is why you are listening this lecture. And this IIT-K, CCE and Shiksha Sopan. All the lectures which are recorded, they are recorded at Shiksha Sopan place, which we call Sopan Ashram, and the editing, the video editing, all these things are done here, and the course management is done by this IIT Kanpur team. So that is one, and in this course we will be having 3 lectures per week, okay, and that will be released on Tuesday, Thursday and Saturday. So in general there may be some changes, but in general the lectures will be released on Tuesday, next lecture will be released on Thursday, next lecture will be released on Saturday. So per week 3 lectures, but then there will be some examinations. So some 4 or 5 examinations will be there, 4 to 5 MCQs, multiple choice questions, MCQ. This kind of quiz will be there, and the total number of quiz we are aiming at 4 to 5. Let's see how it evolves. And the structure of the quiz is also very important to know for the newcomers, and that is, in this quiz you will have questions. Each question will have 4, 5 or 6 options, and you have to choose the correct options. So 4 or more options, A, B, C, D, etc. And then multiple options may be correct, not necessarily one only. You can have 2 correct options out of the given options, 3 correct options, 4 correct options, and so on. So multiple correct options will be there, and you get marks only when, right? You get marks only when all the correct options are chosen and no wrong option is chosen. There is no partial marking. So if let us say we have A, B, C, D, these are the options given, and suppose B and C are correct, these are correct. So if you have chosen B, if you have chosen C, and you have not chosen A and not chosen D, okay, you have to choose all the correct options. So B and C are correct, you have to choose B and you have to choose C, but you don't have to choose any of the wrong options also. If you choose this option also, A option which is not correct, or D options, then you are gone. There is no partial marking, you get 0. You might have chosen both the correct options, but still you can get 0 marks if you have chosen A also or D also, or both of them. Similarly, if you have chosen only C, you have not chosen A, you have not chosen D, so you have not chosen any of the wrong options, but you have also not chosen all of the correct options, then also you get 0. So the only way to get more than 0 marks in a question is you mark all the correct options and don't mark any of the wrong options. So that is how the quiz will be evaluated. We generally give 48 hours of time. In some cases it can be more also, but not less than this. After the quiz is floated, that means we will announce. There is a announcement section on this website. There is an announcement section. When you log in, on the left side you have several items, and there itself it is announcement. Keep looking at that. Keep going there and see if there is some announcement. Okay, so every quiz will be announced well before the quiz starts, is opened in this announcement section. So keep visiting this, keep looking at this if there is some announcement. So if you find that yes, at a particular date this quiz starts, there we will give it starts on, let us say, 17th of September, and then it will close on 19th of September. Time is given 9 a.m. IST is Indian Standard Time, or 9 p.m. whatever. So, those timings will be given here, and for this window of 48 hours at least, this quiz will be open. What does that mean? You can go there in the quiz, and once again on the left hand side you have several items, and there itself you will find quiz. So, you go to that there, and then you look at the questions and you answer them, and this will remain for 48 hours. You can answer the questions and do not submit. Do not submit. You can save. You can save the answer. You do not submit it. Then and take your own time. But if this 48 hours or whatever time is given in the announcement, if that is passed, then you may be in trouble. And there may be many reasons, internet not working well, or power was not there, or this or that. So, well before the deadline you should submit the quiz. Once you have submitted, then it is frozen, then nothing can be done after that. So, this is the examination pattern. Now, the most important part is a discussion board, which we call forum. This is another facility in this CUET platform, that you can ask any question, or you can discuss with your peers, discuss with instructors, anything that you want to discuss on the course, about the course. Okay. So, once you go to this forum, then there is a window where you can type your question, and this question will be visible to everyone who logs in, all your fellow students, all your fellow participants, and the instructors like me. We will all be looking at, we can look at your questions. If you are asking a question, we say that you have created a forum post. If you have initiated, you have put your question there, you have created a forum post, and then anyone who wants to comment on that, reply on that, can reply there, and that reply will appear there. So, you can also apply others post. So, this way the discussion will go on, and I will also be occasionally looking at this discussion forum. It will not be possible for me to look at all the posts which are there, because they are always in thousands in the course, but occasionally I also look at that, and I also reply some of the questions, but then the participants themselves reply to each other, and most of the queries are solved. So, that is the structure of the course. This way the course will go. The total duration will be somewhere between 3 to 4 months. Somewhere around little more than 3 months probably, some 14 weeks, 13 weeks like that. So, you have to be prepared that this is the time, this much time you have to devote together with your college or together with your regular classes and all that. That is about the structure. Now, let us come to this magnetostatics once again. So, let us do some stuff which you did in class 8. So, this is a bar magnet, so normally used in the laboratories. This is another bar magnet. You have this white dot here, which signifies that this end is the north pole and the other end is the south pole. So, if I place the magnet here, north pole is this side, and this other magnet, north pole, is here, and if I bring this north pole close to the north pole of the first magnet, it goes away, right. So, all this you have done fun in class 8 level, and similarly if I bring this north pole towards the south pole, it attracts. Now, the question which we will be addressing here is that this magnet does not repel or attract this magnet. This repulsion that you are seeing here is not the force exerted by this magnet on this magnet, or the attraction that you are seeing here is not the force by this magnet on this magnet. The magnets are supposed to create the magnetic field, the job of this magnet is to create a magnetic field everywhere around, and then it is the duty of this magnetic field to exert force on the other magnets. So, as we did in electrostatics, this is also a two-step process. This magnet is producing magnetic field all over, and whether this magnet is here or not, this magnet is doing its own duty to produce magnetic field. And if there is a magnetic field somewhere and then the other magnet comes there, then we say that okay, there is a force. So, it is the magnetic field which exerts force on the magnet. So, that is one very important thing that everyone should remember. Similarly, we have a compass needle. That also, you know, this is a compass needle, and its needle stays in north south direction unless there are other magnets or magnetic materials or currents in the surrounding. Otherwise, because of the earth's magnetic field which exerts forces on this compass at the two ends, it always stays in north south direction. Now, if I bring a magnet here, then you see what happens. If I bring a magnet here, yes, you can see the magnet is producing a magnetic field, and that magnetic field is exerting force on the compass needle, that itself is a magnet, and that is how we detect the magnetic field. This compass is kind of instrument to detect the magnetic field. If there is a magnetic field, then it will deflect. But you also know that if you bring not a magnet but a normal nail, for example, then also there is a force on this and it deflects. How does that work? The magnet has produced the magnetic field, correct, but how does a nail which is not a magnet, that can also deflect this compass needle? So, look at this nail, it is not a magnet, it is not producing magnetic field, but still if I bring this nail close to this compass needle, you can see that the compass needle deflects. So, now if it is not producing a magnetic field, how come this compass needle is experiencing the force? The thing is, compass needle also creates a magnetic field. This compass needle itself is a magnet, and therefore it creates a magnetic field, and when this nail, iron nail, is placed in this magnetic field, this magnetic field magnetizes the nail. That is a interaction between the material and the magnetic field. If you have a material, a solid material or a liquid material in a magnetic field, then magnetic field interacts with the molecules and atoms and this and that and gets magnetized. Once this nail gets magnetized, then it will produce its own magnetic field, and then that magnetic field will exert force on the compass needle and it will deflect. Okay. So, at this moment my nail is not unmagnetized, it is magnetized, it is a magnet now, but then this nail does not retain this magnetism for a long time. If I move it further away from the field, then this again gets unmagnetized. So, that is the difference between a permanent magnet and a temporary magnet. There is another demonstration very interesting, and that is, you see a solenoid here. You see a solenoid here, and this solenoid is connected to a power source. This solenoid is connected to a power source, and I can just switch it on from here, and then there will be a current in this. Okay. So, if I place this compass needle close to the solenoid, there is no deflection, it will stay in north south direction, there is no current in the solenoid, and there is no magnet, no nail, nothing which can deflect this compass. So, here is the power source, here is the switch, and I will just press this switch to pass current through this solenoid, and you see what happens to the compass. See the deflection, and then I switch off the current and it again goes to its north south position. So, what does this say? What does this say? It says that when you have a current in the solenoid, this solenoid also produces a magnetic field, right. I have switched on, there is current in the solenoid and it produces its own magnetic field, and that magnetic field is exerting force on the two ends, and therefore, it is rotating. So, essentially you have two ways apparently. So, apparently you have two ways to produce magnetic field. One is you just bring a magnet and place it somewhere and you have a magnetic field around this, and another way is to bring a current, pass a current through some circuit, and then around this magnetic field is produced. Now, these two seemingly different, they are not different fundamentally, because what the magnet is, it is equivalent to small atomic currents. You know, in the atom you have electrons and the nucleus, the electrons are in motion. So, those electrons which are in motion, and also there is something called spin of the electron. It is not that the electron is spinning as such as earth spins on its axis, but still it behaves like that, okay. And this spin property of the electron also creates a magnetic field. So, all that actual current because of the motion of the electrons and then the spin of the electron, they all produce magnetic field, and therefore, each atom in this is kind of a magnet which produces magnetic field, but that is from current, and all those tiny atomic currents, they are equivalent to a current on the surface of this magnet. Equivalent, it is not that the current is going from here to here to here to here to here, no. In each atom, all the electrons are loyal to the nucleus. No electron is going away from its nucleus, but then their sense of rotation or their motion or whatever is such that taken together all the atoms, it is as if there is an actual current on this surface. So, this magnet is also a current, right, and that is why you read that a bar magnet is equivalent to a current in a solenoid, and that we had seen here. So, basically both the sources that we have shown is just one physics of it. There is a current and that produces magnetic field. So, that is it, the current, this is the source, current produces B field. However, there is yet another method, there is yet another way where you can create magnetic field without a current, and that is if the electric field at some place changes with time. If you have electric field and if that electric field changes with time, there is a ddt, that also produces B field. But this is certainly not magnetostatics. It is not statics, it is changing with time, something changing with time. The source of this magnetic field that is changing with time is not magnetostatics. This will not be in our syllabus this time. So, we will concentrate on how current produces magnetic field and how this magnetic field interacts with materials and other things. Now, last for today's lecture, books. No matter how I teach and how I speak and how I demonstrate, ultimately you have to go home and revise the things and read the books, and therefore books are very important. So, the main book that I will be following in this course is this, which is Classical Electromagnetism by HC Verma, recently published. So, I will only name the authors and let me name the book also in this case, Classical Electromagnetism, published by Bharati Bhavan. You can get this book from your booksellers or from the website of Bharati Bhavan. So, this is the base book. Then another book will be the famous, very famous DJ Griffiths, Electrodynamics, Principles of Electrodynamics or something like that. So, this DJ Griffiths will be another excellent book. I have extensively studied from this book and taught from this book in IIT Kanpur, and for this lecture series also I have consulted this DJ Griffiths. And the third is by A.S. Mahajan from IIT Bombay, retired professor, and Abbas Rangwala. So, these are the three books which I have consulted, and I have based my lectures on the descriptions given here, descriptions given here, and descriptions given here. So, that is all about the course as such. Next time we will do some real magnetostatics.